Hello YouTube, RJ. Hey, we've got something on the bench that's extremely rare. It is so rare that there's only one of them in existence. And what would that be? That'll be my home-built antenna tuner that I use almost every day. I use this on my 80-meter full-wave loop to use it all the way across the 80-75 and the 40-meter band. It is a completely home-built one-off antenna tuner. And why do I have it on the bench? Well, I've got it on the bench for one reason. I built this antenna tuner a couple years ago. It works fantastic with one exception. As long as I leave this set to go through the tuner on either antenna, it works great. The moment I go into bypass on either one, and I discovered this after I built it, the SWR increases. Now, I've got a theory about what might be wrong, but to be honest, I never pulled it out of the ham rack to take a look at it. I didn't really need it in bypass, but I got to thinking about it. It started bugging me. I really want this thing to work the way I intended it to, so I thought that'd be a great project for us. So that's what we're going to do. So what I'm going to do is I'm going to hook up, test the impedance coming through it, what the SWR looks like coming through in bypass again, and make sure that it is the way I remember it. And then I'm going to dig into it, and we'll see if we can figure out what's wrong and how to resolve it. So what I've got hooked up, I've got my antenna tuner hooked up, and I'll pick up the camera here and we'll let you have a little shot of what we've got going on the bench. We've of course got the antenna tuner, and what we've got is we've got my dummy load hooked up to give me pretty flat, pretty close to 1-to-1. And it's not perfect, and it's supposed to stay within 1.2 to 1. I don't think it quite does that, but it's pretty close. So I've got the Nano VNA hooked up to the input of the antenna tuner. And then the antenna 1 I've got currently hooked to the dummy load, and we'll switch that a little later as we get ready to try the others. But right now, we have the tuner set on going through the tuner and out antenna 1, which is where our dummy load is. I've got the Nano VNA constantly updating, and you'll see that if I churn things, I can tune. This appears to work perfectly fine. The capacitors, of course, make variations also. So from a tuner point of view, it works perfectly fine as long as I use it as a tuner. Either the antenna 1 or antenna 2 works fine. The problem comes in when I go to bypass. If I go to bypass antenna 1, which would be the third selection down on the knob here, we should have a pretty flat response because we should be passing straight through into the antenna tuner. So let me do that. And as you can see, we do not. We don't have that. The antenna tuner no longer messes with it. So we are not going through the tuner at this point. That is correct, but I'm not getting flat SWR. As you can see, it gets quite up there. 20 meters, I'm above 3-to-1. So I need to identify this issue. Now it does the exact same thing on antenna 2 out. Doesn't matter which one we do. Pretty sure it's how I've got the grounds hooked up is my suspicion. So let's get this thing tore apart and let's see what we can see inside. Okay, so I've opened up the amplifier top. Thought I'd let you guys get a view of what it looks like inside. You notice all the copper looking full. It is just that. It's a copper, adhesive backed copper tape used for shielding on guitars and such. This whole unit is 3D printed. I designed it in CAD and printed it on 3D printer. And for shielding to keep RF out of the shack, this is what I've done. The grounds are all interconnected to this. So this is a big grounded shield. Works very well. It's a great method to pull this off with. And so you can see that I have the input and the 2 antennas, and the ground feeds to a common on the variable inductor, the roller inductor, and down to the out. The shields of all the coax are interconnected to each one of them, also running up to the switches up through here. Let me move the camera just a little bit. The coaxes go up to the switch up front. And then of course you have your variable capacitors. I found some very nice variable capacitors on eBay actually. And then I've got vernier knobs for them to give me a, I think it was a 3-to-1, maybe it was a 6-to-1 now that I think about it. No, it's about a 3-to-1 ratio. So it gives me nice fine tuning on the capacitors there. The roller inductor, everything is done with couplers to make sure that there's no binding. This coupler here actually has rubber in it that allows it to give a little bit if there's any imperfection in alignment. It also isolates the front shaft from that. And then on here, I actually insulate a very interesting way because you need to insulate. Otherwise, when you touch the knobs, you'll add capacitance to things. So if you pay very close attention, you'll notice that that looks a little different than up here. That's because that's metal shaft coming out of the vernier controls. And this is actually wood dowel. I actually used wood dowel, hard wood dowel. I turned down on the lathe to make it the perfect size to fit. And I replaced the metal shaft coming out of the capacitors with wood to insulate me, and that took care of that problem. So everything works great other than when you go into bypass. What should happen is you should come in the input over here, should go up to the switch and come right back out to one of these antenna outputs. So you really shouldn't have, you're talking 50 ohm Teflon coax, you shouldn't have any impedance change. But I think what I've got going on is, I believe what's happened is because the shielding for the coax is connected at both ends. If I remember how I did it, I think what I'm doing is I think I'm making a capacitor out of these coax cables. Not positive of that. So what I'm going to do is, I can't exactly remember how it connects to the switch up here, but I've got to get the front off. That's kind of a job. I've got quite a few things to take loose. So let me get that all apart. Let's take a look inside, see what we see when we get there. So I'll be back. Well, I thought I'd be right back, but as it turns out, I had a helper show up. I had to work with him on the bench a little before we could get back to doing anything more. What are you doing? You tuning the antenna? You tuning the antenna? Okay, so after taking a look at the antenna tuner, I think what I've got going on is I've got these long cable runs up to the switch in the front. And I think what's happening is I'm getting some capacitance, of course, and inductance from all of that. And I think that's causing me problems. When I really took a look at good antenna tuner designs and such, they always have either their mechanical switches, they always have shafts running to the back to a switch next to the coax input and outputs so that everything is very, very short. And so this led me to believe that I really need to get to where I'm passing this stuff directly through without all this cable runs to the front and such. So here's what I've decided to do. I'm going to put 3 relays on a circuit board. The coax will come straight out of the input connector on the one side of the tuner, straight over and into this board, straight into a relay. And this relay in its normally closed position is going to pass that signal into the tuner circuitry through some coax and out of the tuner circuitry back into the second. And I've labeled these the in relay, the out relay, and the antenna relay. When relays are in their default non-energized situation, you're going to have the RF input come in, pass straight through the tuner circuit, straight into the out relay, pass through the relay in its normally closed position, pass on to the antenna relay, and in its default normally closed position, it's going to be routed to antenna 1. Now, why did I choose that? Well, because the vast majority of the time I use the tuner circuit on antenna 1 in my setup. So what this means is in default, no power being used. We're in our normal use mode. Now the switch up front no longer will be switching directly anything. We'll have 12 volts coming in. I'll put a DC barrel connector on the back of the antenna tuner, pass 12 volts in. And so this switch is going to control, depending on the position it's at, it's going to energize. These two relays are interconnected, so they're always at the same state. So as I said, when they're not energized by the switch position, they are set to go through the tuner. So two of the positions on the switch, tuner through antenna 1, tuner through antenna 2, will not energize these relays. No voltage will pass these relays. When you change to the pass through, it'll energize these two relays, switching the input to pass directly over to the out relay. From the in relay, it'll pass straight to the out relay. From the out relay, it'll run over to the antenna relay. And what antenna it's connected to will be dependent on where the switch is. If it's not energized, it's antenna 1. If this switch energizes in the particular position you've put it, it'll go to the normally open position and it'll go out antenna 2. That gives me the 4 positions I need. These two open and select these two, and these two closed and select these two. And so with these 3 relays, I can totally isolate the tuner circuit for pass-through by building a small board and mounting it right next to the antenna connectors. Everything will be extremely short. I've got some decent relays picked out for this. So the next step is going to be go ahead and get this circuit board designed, try to decide whether I'm going to order it, have it made, get PCBWay to make me a board, or I'm going to do it in-house. Document that for you, and we'll work through that and build this board, and we'll mount it, wire it up, and see if we solved our problem. This is what we're going to do. So that'll carry us into the next video in this series with this antenna tuner upgrade, and hopefully we'll figure out a way to make this work well. So hope to see you in the next video.